There you go. It's recorded. So if you have any questions, just raise your hand, and we're going over 3.4 today in class. If you haven't downloaded your NHCC app on your phone, please make sure you guys download it because sometimes I don't know how to contact you guys, especially like today we have a Zoom meeting at a very like 2 hours before I post it in detail. So if you did have your NHCC app on your phone, then I post something on it, and so make sure you guys. So I think you guys got my message on my memo in this case. So which is perfect. Yeah, you do not need to have your video running on the background. So today we will talk about 3.4. So let me share the screen and we will go over 3.4 today. So and again, if you have any questions that you have, please raise your hand. So or unmute yourself and then talk because sometimes I'm going through quite fast here. So today we will go over 3.4, which is called the zero of a polynomial functions. Do not forget the word zero has other meanings also. So we talk about that in 3.2, where if you look at what we learn in 3.2, the word zeros of a polynomial functions is also called as the solution, the factor, or the x-intercept, and depends on how you write it. Usually, if I want you to write in the zeros or a solution, the solution, how you write this is x equals to a. But if I want you to write in a factor form, is x minus a in the parentheses. And if I want to write in the x-intercept form, is a comma 0 in the coordinates form. So make sure you guys know the difference here. And I think on 3.3, what you guys did on last week, we talked about syntactic division. This is very important for us. So a syntactic division is where you divide with a divisor of x minus k. And again, this x minus k or x plus k is what we call as the factor form. So when I write in the factor form, when you do the syntactic, you have to make the factor form equals to 0 and solve for x. And that's where you put in down in the syntactic division on this side, okay? So those students who are not here last Thursday, please go through the notes or my instructor notes here, or come and talk to me during my office hours because syntactic division is quite important here, okay? And I also want to point out that in 3.3, you find out that in mostly all the 3.3, when you do this section, the zeros are provided to us. So as you guys know that this is power 3, that means you have at least 3 zeros here. And and they give you at least 1 0. So once they give you 1 0, then you do syntactic division. The power 3 will become power 2. And then you can either factor that power 2, the quotient, or you perform quadratic formulas to find the other 2 zeros. So same thing happens to question 7, question 8 that we have here, is they give you 2 factors out of the power 3, which is good news. And power 4, they also give you 2 factors in this case. So you find out that in section 3.3, they give us the factors, all the zeros of the solutions, and they want you to prove it. That is a 0 using syntactic division. You just perform it and make sure that when you do your syntactic division, your remainder has to be 0. However, in 3.4, you notice that the function that given to us here does not provide you any factors or zeros. So this is where the tough part is. So what we have to do here is you have to try to do syntactic division with any numbers you want, as long as you do the syntactic division correctly and your remainder is 0, that syntactic division or that solution that we have is going to be a 0. Otherwise, you have to retry this countless of times. And so a lot of students kind of struggle in this section 3.4 is because you doesn't know what 0 to start with. It can be start with 1, or it can be -1, or it can be 2 or -2, or any other numbers, even 1/2. It can be fractions. So a lot of students like giving up on this, and some students did this in a test and they erased so much that they got a hole in the test because of all the erasing. So I would strongly suggest you do not use pen, use pencil, especially when you use this section. And that's a lot of trial and errors in this case. And then some students ask, do you have like a shortcut or anything to eliminate some of those zeros? I mean, I know, and the answer is yes. I will show it to you in 3.4. So there are a few theorems and few things that we'll go over here in 3.4. Okay, so the first thing I want to point out in 3.4 in this case is what kind of zeros can we have? Okay, so so we have what we call, so you guys need a little bit of kind of zeros that we can have in this case. Let me pull up my text. So we have what we call as rational zeros. Okay. So what is rational zeros? Rational zeros are zeros that can be represented by fraction. So, again, I will type this and I will also will put it in detail and also send to your email so you guys can copy your notes here. So rational zeros are zeros that represent as fractions. Now we talked about rational numbers before, way back on the first day of class. So remember, we do the chapter P in our first day of class. We talk about which one of the following are rational numbers, and I say any rational numbers means you can write this as a fraction, like 8, 6/3, -22, -1, -1/4, 1/2, -7.5. So decimals that is repeating and decimals that is terminating can be represented by rational numbers. This is what you guys did in chapter P when you select the rational numbers. So now we don't talk about rational numbers, we talk about rational zeros. So when you have a rational zeros means zeros can, any zeros that can be represented as a fraction will be a part of your answer in this case. That means that, you cannot have any irrational. So no irrational zeros or complex zeros, okay? Irrational zeros, no complex zeros. Again, what is irrational numbers? Again, back to what we studied back early on. Irrational numbers are numbers or decimals that doesn't repeat and doesn't terminate, like pi, like square root of 2. So if you put this in your calculator, your decimals is keep on going, doesn't repeat, doesn't terminate. Those are what we call as irrational numbers. So if the question asks for rational zeros, you cannot include this kind of numbers into the solution. Okay. And then we also have another type of zeros that we will learn here. It's called the real zeros. So those are, you need to watch carefully what kind of zeros we have. Rational zeros are zeros that can be represented by rational, which in this case is as fraction, and irrational. So in other words, no complex zeros. So what is a real zeros that I want? A real zeros are zeros that can be represented by any zeros or any numbers we want, as long as it is a fraction or it is irrational. So in other words, if you get pi, √2, 22, -1.75, whatever number you see here, these are what we call as real zeros. Remember last time we learned the complex number that way still in chapter P. Complex number is where we have this I form. Okay, so we have the a plus bi form. So that means that any numbers that is not written down in a complex number form, a plus bi form, will be belongs to the real zeros. Okay, and then the last zeros we'll talk about is all zeros. All zeros means zeros can be real and complex in this case. So all zeros means any type of zeros will take form. Okay, so these are 3 types of zeros we have. So why I point this out to you here is because this is something that you guys need to know. So if you read questions like in 3.4, this asks us to list the possible rational zeros. And then this is asking for all real zeros. So when I ask for real zeros, they're talking about that zeros that can be rational and irrational. And then sometimes when you read the questions, this one says, again, list all the rational zeros. Again, what are rational zeros? Rational zeros are zeros that can be represented by fractions. And then they want you to list all real zeros. Okay, and again, real zeros means you cannot have complex zeros. Any numbers is work. Okay, and then they want you to find the point. We'll talk about that later on. This, they want you to find all the zeros. So what happens when I ask you for all the zeros? So all the zeros represent zeros for anything, real, complex, fraction, rational, irrational, any A plus EI form. So that is what they want you to do here. So make sure you guys know this, because this is what, and the last question also asks you for all zeros. So so make sure you guys understand this. Very, very important, especially in the homework and in the test. Sometimes I ask for all zeros, sometimes I ask for real zeros, and sometimes I ask for rational zeros. And these three types of zeros are very different. Okay. So those are the types of zeros we have. So make sure understand that. Next, we'll talk about the fundamental theorem of algebra. So what is the fundamental theorem of algebra says? It says that if you have a polynomial of degree of n, power of n, then you will have at least 1 0 in a complex number. This is the fundamental theorem algebra says. If I put it in the context form for this case, that for the fundamental theorem of algebra, it says that if you have a polynomial degree of n, then you should have n zeros, and these zeros can be all types of zeros. So again, what is the meaning when I say all types of zeros? Means your zeros can be real, your zeros can be complex. So what is that telling us in this case is, let's say for example 1, if you see this is a power 3, so we should have 3 zeros in this case. That 3 zeros can be all 3 real, all 3 complex, or combinations of real and complex. Okay. And if once you see a power 4, then that means using the theorem, fundamental theorem of algebra is telling us that this question 2 will have 4 zeros. And these zeros can be complex or real, can be fractions. So there are 4 of them. Okay, so this is very important. Again, mostly what I tell you in the class is we always do power 3 or power 4. That's the highest I give it to you, because once I hit power 5 and 6, it will take you a page to 2 pages long to do it. And again, in your test, you don't have time to do those. Okay. So that's why I just want you guys to do something less work in this case. Okay. This power 3 or power 4. Okay. The next thing we're going to talk about here is linear factorization form. What is linear factorization form? A linear factorization form means you can write all your factors or all your zeros in a factor form. We did this in 3.3, where if you find your factor is 5, then you put x minus 5. If your factor is 2, minus 2, then it's x plus 2. And you find out this linear factor form has this an. Okay. So this is where I got some students asking me some questions in your homework here is, let me bring out the 3.3 notes in this case, so you guys can see what I'm talking about here. My office hours is every Monday and Wednesday from 4 to 6:30 is in my syllabus. So please do stop by in my office hours. Otherwise, you need to make an appointment with me. Okay. I do have a class right after this class, so I cannot meet you after the class here, but I do have classes. I'm free before this class. So if you have any questions, you have to, come and make an appointment with me for that case. This is what I talked to you last time about the linear factorization form is you write your factor as this case, okay? So this is called a linear factorization form, or this is what a linear factorization form in this case. I just want to point out some students were asking, should I put the 10? Remember, that's a 10 in here. Should I put a 10 in front or not? Okay, so in order for you to figure this one out, you just need to multiply. And so what I always tell my students, look at your f of x. The leading coefficient in this question 7 is 10x cubed. And if you multiply all your completely factorization from 2x, 5x, and x, so 2x times 5x is 10x squared times x, which is 10x cubed. So guess what? If you multiply all this first one, 2x, 5x, and x, you get 10x cubed. Then you do not need to put the 10 in front. Okay, this is something that I want to point out to you. Very important case here. So this 10, so you just need to do a little bit of math to figure out. And what happens if this is not a 2? This is just an x, and this is just not a 5x, it's just an x. So you may multiply x and x and x, you get x cubed, but you have 10x cubed in question 7 here. So that means this 10 you have to put in front here. So in other words, that when you talk about this, an in front of it, you need to figure out, do we need to put this an out or not, the 10 in this case. Then you just need to do a little bit of multiplication. And sometimes you can tell that if you start with x, x, and x, and you got a 10 in front, yeah, you probably need to put a 10 in front of it. But if you have numbers like in this case 2x and 5x, then you do not need to put a 10 in front of this complete factorization form. So this is called a complete factorization form. This is based on the zeros that you have. Okay, so so some students did this in your online homework 3.3 is, let's say you found this is your zeros and you try to find what is the complete factorization form. Okay, I'm going to use a bit shortcut here. So so a lot of people say, oh, negative 5 over 2, then this will become x plus 5 over 2. And then you have the 3/5, so it become x minus 3/5. And then the last one that we have in this case is 3. So the factor form for the zeros of 3 is x minus 3. Now this, when you if you write this in a complete factorization form, then you need to put a 10 in front here. Okay. The reason why is because when you multiply all this front xxx, you get x cubed, but our question have 10x cubed, so that's why you need a 10. So this is how you write this as a complete factorization form. Or if you do not want to put a 10, you just write this as fraction, because we can write x plus 5 over 2 as 2x plus 5. You multiply everything here by 2. That's why you get 2x plus 5. And if you multiply this whole thing by 5, you will get 5x minus 3. And then you have x minus 3 over here. So if you write this as a complete factorization form, then the 10 in front is not needed. It's because when you multiply 2x and 5x, you get already the 10 in front. So, so make sure you guys know when do you use the 10 and when do you not use the 10 here. I can tell you straight away, if your x in the if your leading coefficient of this factor form is all 1x, then usually you need to put a number in front of it based on your question here. But if you already have number in front, then you do not need to worry about it. And as the last thing you need to do here is, don't forget to label this as f of x, the function of x, because this is in the function form. So make sure you have that at the end. So this is what we call as complete factorization form. And that is what we're talking about in this part here. Okay. So it looks something like that. So don't forget the f of x and then all this factor form. Okay. So this is something that we already did in 3.3. I just bring it out to you guys so that you guys know why there's sometimes an an in front or not. Okay. So so I know some of you asked that in the homework. So now, as I mentioned early on to you guys, is as you guys know that you're not trying to do syntax because this question did not provide us any zeros. So you are trying to find the needle in the haystack, and you will say, oh, let's do syntactic division frantically, like, oh, 1, 2, 3, 4. So is that a shortcut I mentioned, right? The answer is yes. And what is the shortcut called? The shortcut is called the rational zero test. Okay. Now, what is this shortcut do to us? This shortcut is actually will tell us the possible rational zeros. So what is looking, if you look at question A in here, they call us to list the possible rational zeros, means that you have to use the rational zero test here to list it. Now, what do I mean by the word possible rational zeros? Possible means maybe. So that means that this theorem or this test is just give us some rational zeros. Some of them is maybe right and maybe is not right. So that means that out of all the numbers we have in the number line, so there's a lot of numbers in number lines, this rational zero test is just calling us to, okay, let's us eliminate some of those are bad ones. And let's concentrate on those good ones. And although those are the good ones, not necessarily every one of those are the best ones. So we're looking for the best one. So the good ones that we find is called possible rational zeros. But then when I ask you for the all real zeros, I want the good one. Okay, the really great one. Okay, so make sure you guys know the difference between. So if a question asks for the list, you have to use the rational zero test. Otherwise, if a question asks you for the real zeros, you will have to give me all the real zeros. Okay. How do you figure out your rational zero test here is depending on two things. One is your leading coefficient. Okay. So when so one is based on the leading coefficient of an, and the other one is based on the leading the constant term a0. Okay. So an is called the front one, whatever, and a0 is a back one, no x. Okay. So using this rational zero test, you can get the possible rational zeros given us p over q. And what is p is? P is the factor of the constant term a0, and q is the factor of the constant term of an. So don't forget, factor means what times what of that. Okay. Example I can say is example like this question number 1 here. If I want you to give me the list of possible rational zeros, so what we do in this case class is you figure out what is your p. So question A here. What is p is? P in this case is, if you look at the rational zero test, is the factor of all the constant term. So constant term in this case is 12. Now, we don't care about the negative sign. I will tell you why. So if you have a negative or positive sign in front of the number or the coefficient, we don't really care about it. And what we need to do is to give me all the factor of 12. And again, factor means what times what is 12. So it can be 1 times 12. So I will leave it like that. And then you go to 2. So 2 goes to 12 6 times. So 2 and 6. So this is usually how I list all the possible factors here. And 3 also goes to 12, which gives us 4. And then you have the 6. So 5 doesn't go to 12. And then the rest one is 6 and 12. So the factor for 12 in this case is going to be 1, 2, 3, 4, 6, and 12. So these are all the factors of 12 that we just did here. Okay. So that is always P, which is a factor of the last term. Q in this case is the factor of the leading coefficient, an. Unfortunately, there is no number in here. So if there's no number, it means that your leading coefficient is 1. Okay. So in this case, your Q in this case is 1 because your leading coefficient is 1. And what is the factor of 1? Factor of 1 in this case is just 1. Because 1 times 1 is 1. That's only one factor in this case. So, so what we do to figure out what is the list of all the possible rational zeros here? list of the possible rational zeros. You begin to take all the p's that you see here and you divide by your q's. And then you need to put plus minuses in there. So to list all the possible rational zeros, first is 1 over 1 is 1. So it's plus minus 1. And pardon my plus minus, I don't have a plus minus symbol in my keyboard. And then you take the 2 divided by 1, so it's plus minus 2. And then you take 3 divided by 1, which is 3, plus minus 3. What does that mean is that that means this can be positive or negative in this case. And then 4 divided by 1, plus minus 4. And then 6 divided by 1, plus minus 6. And then the last one is plus minus 12. 12 divided by 1. So this is the list of the possible rational zeros. So what is this list telling us? It's telling us that some of these numbers that we listed out here will be your zeros. Not all, but some of them. So that means that when you perform syntactic division, you will be syntactic division with the zeros of 1 plus minus, 2 plus minus, 3 or 4 or 6 or 12. One of those. Okay. So that means that we do not want you to do 1/2 or 5 or 7 or 8, because I will guarantee you those numbers that is not in here will not, when you syntactic division it, you won't get a remainder of 0. I will teach you, Kaylin, what happens if your division, when your Q is more than 1. So if let's say you got 1 and 2, so you take all the factors of 12 divided by 1, and then you do all the factors of 12 divided by the next one, and you have the list. So that means the list is going to get a lot more bigger than if you have just 1. You will see that in question 2, okay, where you will find your factor here has on the Q is more than 1. Okay, so if your Q has more than 1 factor, then you probably have a bit more to do. Okay, so how do you write this in your online homework? I think you guys are aware that your online homework do not like the plus minus sign. So that means that these possible rational zeros that you give it to us, to give it writing here, has to be written down as 2. That means that you have to do +1, comma, -1, comma, +2, comma, -2, comma, and so on, so on. So when you write this in your online homework, make sure you don't use the plus minus symbol, because your online homework will mark you wrong in this case. But in the test, yes, surely I understand what is the plus minus 1 is. Okay, so now we got the list of possible rational zeros. Now we have to, question B in this case is we have to list them. So how do we list these possible rational zeros? You have to perform syntactic division. Okay, so what we do here is we're going to pick syntactic division by the coefficients. Again, this is what you did in the previous section here. 3.3, 1, -9, 20, and -12. So these are your coefficient that we have. Okay, and as usual, we always drop the 1 down here. Okay, so now we will try to do syntactic. So you have to try using these possible rational zeros. So you have to try to use 1. And our main goal here is your remainder has to be 0. If your remainder is not 0, then you have to restart this syntactic division and change it to -1. And you have to repeat this syntactic division until, again, 0. So this is where a lot of students say, David, I don't have time to do this in the test, because, you know, you have to try it 2, 4, 6, 8, 10, 12 times, right? I don't have time to do 12 times. So my piece of advice to you in my test is I won't give you the last 2 rational zeros. So I will tell you that in my test, usually if you did 1 or 2, usually it will give you the zeros. Okay, so what we did here is let's start with 1, because we always start with 1 first. We go to the list here. Again, don't start from the back. Start from the 1, 2, 3 first. And if you have fractions, don't start with fractions. Okay, so perform syntactic. 1 times 1 is 1. So we add this up, become -8. And then you multiply this, you get -8. 20 minus 8 is 12. And 1 times 12 is 12. And this is good news. So 0. So guess what? This is good news. This is what we want. So that means that 1 in this case is good. Okay. Now, as you guys aware about this, that this question 1 is power 3. So when you have a power 3 means you have 3 zeros. And so far you only found 1 zeros. And then some students ask me, can I continue perform syntactic division 2, 3, 4, 5, 6 of 3 or 5, 2, 3, 4, 6, 12? You can, but why you want to perform syntactic since the quotient that you get here is already power 2. And again, once you get into power 2, we can find the other 2 zeros using factoring or quadratic formulas. So when you try to write this quotient in the form, you will get x squared minus 8x plus 12. And this can be done very easily by factoring. And we kind of figure out that the factor for 12 in this case is 6 and 2. Okay. And to make them negative, these two has to be -2 and -6 to making -8. So this is a factor for this case. So what we do is, in order for you to find the zeros, because this question wants us to figure out the zeros, you set this all equals to 0. So you will get 6 and 12 and 2. So in this case, that if a question wants us to list all the real zeros we have, then your answer in this case will be 1, 6, and 2. Okay. So when you perform, so again, it's very difficult to do this in the Acrobat, this PDF form. So again, you have to use, I use that pane, so it's easy for me. So it's there again, class. It's very difficult to teach via Zoom. So you have to actually quite a bit of windows that have popped. So when you perform a syntactic division, 1 is a 0 of this case, and then what you do next is factor the quotient, usually it's factorable, to find the other zeros. So this means that for this case, your real zeros in this case will be 1, 2, and 6. So this is your answer for question B. So 1, 2, and 6. Again, the orders is not important. Some students say can do 6, 2, 1 or whatever, 6, 1, 2. Not important orders as long as they're all in there. Okay, so make sure these are the answers for this case. Okay. So what is this stands for in the form of graph? Okay, so if I pull out my Desmos calculator here, and if I graph x cubed minus 9x squared plus 20x minus 12, you notice that these are your zeros, or on the graph we call the x-intercept. It will cross at 1, 1, 0, 2, 0, and 6 zeros on your x-intercept. So don't forget, zeros and x-intercepts are the same thing. So finding the zeros here is the same thing as finding the x-intercept. So in the graph means it will cross at these 3. And why I say cross, not touch, the reason why I say this is cross is because the power that we have here is all power 1, multiplicity of 1. So this is, again, you learn 3.2. When you have first multiplicity, all your points, all your zeros, or all your x-intercept will be crossed, not touching it. Okay? So that's why it's very important. Now what we do is we try to link all the chapter 3 that you learn. Multiplicity, leading coefficients, your zeros and everything, and you can graph this really, really nicely, and you can find these zeros by using it. So this is how we find the real zeros for question 1. So in the test, as I mentioned, usually you will just do 1. If 1 doesn't work, try -1. If -1 doesn't work, try 2 and -2. I will guarantee you is one of these 4 numbers, you will get a 0 in your remainder. And if you don't get 0, please check your arithmetic works in here because it will, that means you did something wrong here. Okay, I do not want you guys to spend time trying to figure out which one is which, because it's very difficult. Okay. So repeat again question 2, similar type of questions. This is where Caitlin asked me about what happens if your factor in Q has more than one factor. So this is question 2 looks like. So again, in question A, we are doing what we call as listing the possible rational zeros. So in order for us to list this, you have to figure out what is your P and Q. So sometimes I call list the possible rational zero as PQ. So that means, so you guys know. P in this case is the last factor or last number here in your polynomial functions here, which is 24. So now you have to give me what is the factor of 24 in this case. So factor of 24 is 1 times 24, 2 times 12. Okay. 3 also goes to 24 8 times. 3 goes in there 8 times. 4 also goes in 12 6 times. So what I do is I keep going 1, 2, 3, 4, and 5. 5 cannot go into 24. And then the next one is 6 because 6 already did, is a factor of 4. And then the next one is 8, which is 3, 12 is 2, and 24 is 1. So this is how you get the factor of a number. Also, that's how we figure out the factor for P. And then we have the factor for Q. What is Q? Q in this case is your leading coefficient. In this case is 9. So what is the factor for 9 in this case? So what times what is 9? You get 1, 3, and 9. Because 1 times 9 is 9, 3 times 3 is 9, and that is the only factor goes into 9. So now we have to list all the possible factors. Okay, so in order for us to list this, you have to do the plus minus. And this is the trick I always tell my students. I put it down a little bit so you guys can see. You take all the P factors, in this case 24, divided by 1. So 1 over 1 is 1. Now, then you do 2 divided by 1, so it's 2. And then plus minus 3, 3 divided by 1 is 3. Plus minus 4, 4 divided by 1 is 4. And then 6 divided by 1 is 6, plus minus 6. Plus minus 8, plus minus 12, plus minus 24. So this only work at this possible rational zeros only go from these numbers of P divided by 1. And now we will repeat again. You have to take all the factors of 24, the blue one, divided by the factor of 3. Because we're going to do 3, and then you repeat again, do all this divided by 9. Now, if the factor that you, the possible rational zeros that you found here is being repeated, you do not need to rewrite it. Example is, let's do 1. So let's take 1 over 3. So 1 over 3 is 1/3. So you get the 1/3 fraction in this case. And then the next one is 2 over 3. So we will have plus minus 2 over 3. Yes, you will get a bit more in this case. Now the next fraction, the next possible rational zero is 3 over 3. And we know 3 over 3 is 1. 1 is already here. So you do not need to repeat that again. Okay, that's what we call we don't repeat. The next one we have is 4 over 3, which is 4/3. Okay, and the next one is 6 over 3, but we know 6 over 3 is 2, and we already have the 2 here, so we don't need to repeat it. The next one is 8 over 3, we don't have that. 12 over 3 is 4, so we have 4, and 24 over 3 is 8, and we have 8. So those are the one that is having the factor of 3 in the denominator. And then you have to do one more in this case. You have to take the same factor P, the blue one, and now you have to divide this with the last one, 9. So we will have plus minus 1/9, 2/9, plus minus 2/9, and then 3/9. Now 3/9 can be reduced to become 1/3. So that means that the 3/9 can be ignored or skip it. Okay. 4/9. Yep, we need 4/9 because 4/9 is not there. 6/9. 6/9 can be reduced to become 2/3. So that means you do not need to represent that again. 8/9. So we need to write 8/9 because 8/9 is not there. And then 12/9. 12/9 can be reduced to 4/3. So you cannot need to repeat that. And 24/9 can be reduced to become 8/3. So that means you can also skip that. So guess what? These are the list of all your possible rational zeros. There's a long list. And again, if you do this in your online homework, you have to write each of these possible rational zero twice. One for the positive, one for the negative. So make sure you guys write this correctly, separated with commas. Some students just look at me and they will roll their eyes. I understand what you mean. It's going to be a long list. But in a test, you can use the plus minus symbol in this case. Okay, so a lot of work here. And as I mentioned in the test, that you only need to try 1 and 2. Okay, and the bad news about this question too is this fellow starts at power 4. So remember last time this is a power 3. So when you do power 3, you just need to perform syntactic division one time if you're lucky. And if that one time gives you a remainder of 0, then your power 3 will become power 2, and then we can use factor to figure out, or we can use the quadratic formula to figure out the other remaining factors. But for this question 2, this power is no longer 3, this power is 4. Okay, so what happens when you have a power 4? So in order for us to have a power 4, then you have to do the syntactic division twice. That means the first time you do, the power has to be 0. The second time that you do have power 0. So you have to do it twice. And once you do it twice, the power 4 will become power 3. The power 3, do it another time, become power 2, and then the other 2 you can factor it. Now, boy, oh boy, look at all these numbers. That is a lot of numbers we have to perform syntactic. Okay, sorry, I'm gonna try to do something here so you guys can try to figure out how to perform this so you guys can see one screen. So I told you teaching on Zoom is not fun. So, so for question number 2 here, so we begin to do syntactic division. So we will start with number 9, negative 9, negative 58, 4, and 24. And again, usually we will drop this 9 and perform syntactic. So the first number we will try here is definitely 1. And our main goal is to get your remainder to become 0. So 1 times 9 is 9. Add them up becomes 0. 1 times 0 is 0. Add them up is negative 58. 1 times negative 58 is negative 58. And if you add this, it's negative 54. And 1 times negative 54 is negative 54. And you kind of know that this will not gonna give us a 0 as a remainder. That means that 1 is off this list. Okay. So in other words, what you need to do is take an eraser or restart everything again. So you have to kind of erase everything. And now you will start this back at negative 1. So you have to repeat this. So that's why some students say this is a lot of work, but correct. Okay. 9 times negative 1, we get negative 9. Negative 9 plus negative 9 is negative 18. Negative 1 times negative 18 is 18. When you add this, it will become negative 40. Again, class, make sure you have a calculator. If you don't have one, please get one. Negative 1 plus negative 40 is 40. And when you add this is 44. And when you multiply that with negative 1, it's negative 44. And we know that this fellow also will not get 0 as your remainder. So in other words, class, your 0, your negative 1 and positive 1 will not work in this case. And guess what? That is just part of your list here. So this is where I say this is tedious in this case. So how do we split things out here? Or how do we really, find all these zeros? If you don't have decimals calculator, then you have to start doing with 2. And 2 doesn't work, negative 2. And that doesn't work, then you start doing 3, negative 3, and so on, following the list, okay? But since we have a decimals calculator here, so we can actually do some shortcuts. So sometimes in the test, I provide you the graph. The reason why I provide you the graph is because that means that questions, the zeros are a little bit hard to find, or in this case, you got a lot of these zeros and you do not want to go through them one by one. So I just give you this graph so that it will make your life way more easy. So this graph that I just typed it over here is represented by this red line here. And you can tell that there are some zeros, and the most easiest zeros you can noticeable here is negative 2 and 3. Okay, so that's the reason why that sometimes when we do this type of questions, I'll provide you a graph. So using decimals graph, it crosses the x-intercept, the zeros are negative 2 and 4. Okay, so the reason why I do this is to speed things up here. Not 4, 3 actually, negative 2 and 3. It doesn't cross at 4, it crosses at 3 here. So especially when you have a power 4 types, especially in your test, you don't have time to do one by one. So I will give you that zeros, your x-intercept. So you need to know this. So yes, let's try negative 2 here. So this will give us negative 18. When you add this is negative 27. And when you multiply this, you will get 54. This will give me negative 4. Negative 2 times negative 4 is positive 8. 4 plus 8 is 12. And negative 2 times 12 is negative 24. And you get a remainder of 0. So as you guys know, that is going to be right. Since if you look at the graph, it crossed at negative 2. Now, since we need to find the other zeros, so you have to perform syntactic division again. And this time you have to do it by 3. Because the decimal says because of 3. Now, sometimes you doesn't know what is this number again, because if you go in here, you kind of know the number here, but usually in your homework or in your test, you doesn't know what is that number. So this number we know is going to be a fraction number because 1 is somewhere here. So it's going to be between 0 and 1. And we know that by looking at the possible rational zeros, we have quite a few fractions here. So that's why we know it's going to be a fraction in this case. But we know these are the 2 nice whole numbers. So again, we're going to do syntactic division here by 3 based on decimals or graph. So 3 times 9 is 27. You get a total of 0 here. 3 times 0 is 0. A total of this is negative 4. And then 3 times negative 4 is negative 12. And a total of 0. So in this case, using the decimal graph or using a graph provided, we found out that yes, the 2 and the negative 3 are 0 in this case. So what happened now is power 4 become power 3. And power 3, the new one that you find here is going to be a power 2. So that means this quotient can be written down as 9x squared minus 4 equals to 0. And again, because there's no x terms here, your x term is 0. So what we do here is once you get yourself into a quadratic type, you can either factor it or use quadratic formula. So what do we do here is this one can be factored because these are perfect square and it's 2 terms. So what is a perfect square for 9x? Is 3x minus 2 and 3x plus 2. So these are the factors for him. And you set each one of these equals to 0. So when you set this equals to 0, your x in this case is 2/3. And you set this becomes 0, x become negative 2/3. So in this case, what are your possible rational zeros here? Don't forget negative 2 that you did, 3 that you did, 2/3 and negative 2/3. So in this case, you will have 4 rational zeros. So again, you are by syntactic division. So you have to do this. And class, in the test, you have to show me all these things, all this case, the one over here. Okay. The quotient we have left is 9x to the power of square minus 4 equals to 0. And so when you start to factor this, your zeros in this case will be negative 2, 3, 2/3, and negative 2/3. So you will have 4 zeros in this case. And these zeros are called the real zeros. Okay. And if you look at your possible rational zeros, you find out that negative 2 is here, positive 3 is here, and the 2/3 are there too. So you find out that that means out of this whole list, those are the real zeros here, but the rest is just possible. So that means out. Okay. So this is how we kind of like doing a little bit shortcut for this case. Anyone any questions here so far? Question 3 and 4, similar. Okay. So so again, we will try to perform find the list of possible rational zeros, means PQs. I just short form is PQs. And determine all real zeros. You have to syntactic division. And make sure that your remainder is equal to 0. Okay, so that is what we do for this case, similar like what we just did here. So again, if a question in the test, if I don't give you a graph, that means your 0 is either 1, positive, negative 1, 2, or negative 2, one of those. Okay, and then you try to find the other one. But if I give you graph or decimal graph like this, you can find the zeros by looking at the x-intercept. So for this case, we repeat the same thing. So P in this case will be the factor of the last one, which is 3. So what is the factor for 3? Anyone remember? Factor for 3? So what times what is 3? Should be easy. Anyone? Factor of 3?
3 times 1.
Yep. So in this case, it's 1 and 3. Again, I can use 3, 1, but I put it in nice order, so it's easy for us. Q in this case is the factor of the leading coefficient. So again, please drop the negative. You do not need to have the negative here, because when you write the plus minus in the possible, the plus minus include the positive and negative. So that's why I dropped the negative. Do not worry about that. So can someone tell me what is the factor of 4? Anyone? What times what is 4? So open the chat room. 2. What else? So 2 times 2 is 4. So we just put 1 time. What else is also factor of 4? What times what is 4? 1 and 4. So that means that your factor of 4 in this case is 1, 2, and 4. Okay. Now what we do is, in order for us to list all the possible rational zeros, you take the P divided by Q, put a plus minus sign here. So again, you take the first two factors, 1 and 3, divided by 2. So you get 1 and 3. Okay, 1 divided by 1, 3 divided by 1. So 1 and 3, don't forget the plus minus. And then what's the next? You take the 1 and 3 again, and now you divide it by 2. So you get 1/2 and 3/2. Okay, forget the plus minus. And then the next one is take the 1, 3 and divide it by 4. So you get 1/4 and 3/4. So these are your possible rational zeros in this case. Questions with me? B. Now we have to figure out your real zeros. So I'm going to start this from new one. So again, I will save all these documents so you can see it when the class is over or the class is done. So you can go. Please rewatch this video again. Okay. So new one. So we're gonna start doing syntactic division for question 3. So that's the reason why that this section is a little bit more difficult than the previous one. So the first coefficient is -4, 15, -8, and -3. And don't forget, class, if you have a missing term, like an X term, you have to replace it with 0. Okay. Now, because I don't have time to syntactic, yes, in the test, you have to syntactic with 1, -1, or 3, -3. I'm going to use my Desmos friends here. So some of you will say, David, can I use this in my homework? Well, if you want to do this in your homework, then I will say go for it, but make sure you know how to use syntactic division here to divide them. But you only pick one. Don't say, oh, by looking at my Desmos, my answer is 3, 1, and this, which is you can turn it into fractions. Then you're not learning the right way, because in the test, you are not allowed to have a Desmos or a graphing calculators. So that's the reason why that we have a scientific ones. So, but I just provide you this graph. So what is a nice number we can syntactic division here? 1. So, so we will try to do 1 in this case, and you know 1 is part of this list here. So we will perform syntactic division on 1 in this case, which it will work. 1 times -4 is -4. Add this will become 11. Multiply this to be 1, 11, get 3. 1 times 3 is 3, and you get a remainder of 0. Okay. Now, usually, you will, if you are lucky, if you know what is the next 0, in this case is 3, you can perform syntactic this with a 3, but this is good enough for us because this, your quotient that you get here is only power 2. So when you perform power 2, we can factor this. Okay. And if you do not like factor, syntactic division, quadratic formula here. Okay. Now, when you do factoring, you do not like this negative in front. But if you do the quadratic formulas, you can have a negative. So the first thing I do here is to multiply the whole thing by -1. So this will give me 4x squared minus 11x minus 3 equals to 0. And what we need to do here is factor it. Now, the bad news is the factor here is the AC method, or we call it the tough three factors, because the leading coefficient is a 4. So 4 times -3 is -12. So now you begin to figure out what times what is -12. But when you add them, you get -11. So there's only one factor that, or one pair will go in there. negative 12 with a positive 1. Because when you multiply this, you get negative 12. When you add this, you get negative 11. So you're going to do groupings here. So you will split these 3 terms to become 4 terms. So 4x squared is the same thing, and negative 11x become negative 12x plus 1x. Again, we did this on the first day of, first few weeks of class. So we do I'm going to teach you factoring here. And you're going to do grouping. So we're going to cut this right in the half, 4 terms. So common factor here is 4x. You will left with x minus 3. And then the common factor on the last one has none. So if it's no, it means you take out still a 1. You still get back the x minus 3. And this 2 is the same factor. So the factor in this case is x minus 3 with 4x plus 1. And once you finish factor this, you set this equals to 0. And this will give us 3. And when you set the 4x plus 1 equals to 0, you will get x is negative 1, 4. Minus 1 and divide 4. So your 0 for this question number 3 will be 1, 3, and negative 1, 4. Okay, so these are your zeros for question 3. You guys all right? So your real zeros, all real zeros, is 1, 3, and negative 1, 4. Okay. So for me is I want you guys to try to do question 4. This is your homework. Try to do this again like what we just did. Find list the possible rational zeros, the PQs, that what we just did here. And then after that, using this possible rational zeros, you have to figure out your real zeros, part B. If you need, you can use a scientific, your Desmos graph. Again, this Desmos graph is free to all students. You just need to search Desmos graphing calculators in your search engine. And you will use it's free for everyone. And you just need to type this equation, this function out here without putting the f of x and the equal sign. And you will draw the graph, and then you pick one of the 9 zeros here. And then you perform syntactic division. And then the leftovers, you just factor it or use quadratic formula to find the other zeros. So I want you guys to go home and do this. And yes, there is a if you want to know how to do this using, I posted the key in D2L, so you just need to look at it. Okay, so try to do this. It's a good practice. You think this question is coming up in your test 2? Yes, this is definitely coming up in test 2. Okay. All right. So we still have one more theorem left here. So this is a theorem that we have left. So we're gonna choose the last theorem here. So very important theorem. This theorem is called the complex conjugate zero theorem pair. So what is this complex zero conjugate pair means? Now, as you guys know that the meaning of conjugate is same number, different sign. For example, is if I give you 3 plus 2i, it has to be complex numbers, a plus bi. What will be your conjugate in this case? Anyone remember? It will be 3 minus 2i. Okay, so the word conjugate means the sign is the different, but your numbers is the same. Okay, and what happens if I say negative 3 plus 2i? What is the conjugate in this case? Now, not 3 minus 2i. This is not the real conjugate. The conjugate is what? Negative 3 minus 2i. So that is the conjugate of this case. Now, what is this conjugate zeros conjugate complex zeros pair stands for. This is the meaning of it. So the meaning of this fellow is telling us that if a plus bi is a zero of this function, then the conjugate a plus bi is also a zero. Okay, so in other words is if you find out negative 3 plus 2i is a zero of a function, then automatically negative 3 minus 2i will be the zero. So if this is a zero, then this is a zero. So this is only work for complex number, a plus bi. It does not work for any numbers like last time what we did. Oh, David, if 2 is a zero, then negative 2 is a zero. No, not for rational zeros, not for real. Only work for what? Complex zeros. Okay, so make sure you guys know that only complex zeros can only support this theorem, not 6 or 1 or 2 or 2/3. That doesn't work. Okay, and another type of zero is square root. So if 3 plus square root of 5 is a zero, then the conjugate, which is 3 minus square root of 5, is also a zero. So conjugate. Okay. So only the square root and the I, the complex, can have this conjugate pair. It's not work for numbers like 2 or 6 or 3 or something else. Only the conjugate pairs. Now I bring out why that this theorem, only the conjugate pairs for the complex number and the square root numbers can have a zero in this case. It's all based on your quadratic formula. Okay. So remember what we did way back in chapter 1 when we solve equations. When we solve equations using quadratic formulas. So this is back in chapter 1. You notice that when you solve like question number 3 here, you try to use the quadratic formula here. You find out this is your answer. You find out this answer is called the conjugate square root. If you know 1 plus root 3 over 3 is a zero, then automatically 1 minus root 3, 31 over 3 is also a zero. So that's why when you see a square root, if you remember in the quadratic formulas, we have the plus minus. That will give us what we call as the conjugate pair. So if this is a zero, then the minus is also zero. But also remember same thing with this. If 2 plus root 5 is a zero, then guess what? 2 minus root 5 is also zero because it's a conjugate pair. So every time when you see a square root, if you think about conjugate pairs, we can use the plus minus. And same thing happens to your I. So if 1 plus I root 11 is over 8 is zero, then 1 minus I root 11 is also zero. So that means this is called the conjugate pairs also. So every time when you see the I, the square root, or even the combinations of I and square root, then we find out that these two are conjugate or zeros. And usually in the test, or in the homework questions, I only provide you one of the zeros. Then make sure you know that the other zeros appear or have it. Okay. So what do I mean in this case that I say 1 by 1? So this is like question number 5. So if you read question number 5, this question only provide us 2 zeros, 4 and negative 3i. However, there is a missing zeros in this case. That missing zeros, anyone want to guess? That missing zeros. Can someone tell me what is the conjugate of negative 3i? Nope. Again, your conjugate zeros cannot take this because it's only work for I, complex, and square root. So 4, you cannot use negative 4. So the only conjugate that we have is this I. And what is the conjugate of negative 3i? It will be just 3i. So make sure you guys know this is very important. The conjugate zeros only happens on what? Two types of zeros. If you have I or a square root. So if you have I or square root, then we will have the conjugate pairs. But if you have just a normal number like 4 or negative 3 or negative 1, 4, we don't have a conjugate on it. Okay. So now this question wants us to find what is the polynomial function. So now I give you the zeros. How do you give it to me as a polynomial functions? So we work backwards now. Last time I give you functions, you give me the zeros. Now I work backwards. So in order for us to do this, you have to write these zeros in a factor form. Okay. And how do you write this zero in a factor form? You minus them. So we put an x. So parentheses, x minus, and the first zero is 4, so it becomes 4 here. And then the next factor will be negative 3i. So don't forget the x, but you switch your sign. So that means that it becomes plus 3i. And then the next zero is 3i, but when you put in there, become x minus 3i. So don't forget, when you put in a factor form, parenthesize it, and then put x on each one, and then all your zeros, you switch your sign. Okay. Now, what you need to do in this case is you have to FOIL it out. Okay. Now, so who do I need to FOIL first? Now, as you know that when you multiply, you can multiply these two, FOIL these two out, or you can FOIL the back two. My suggestion, this is what I will always tell my students, please FOIL these two out first. Okay. Why I want you guys to FOIL the conjugate out first. The reason why I want you to FOIL the conjugate out is because of the middle term will cancel out. Okay, because when you FOIL the in and out, one is a positive and one is a negative, they will cancel out. So when you FOIL this, you get x times x, which will give me x squared. Oops, actually I can write it down here. And then the positive 3i times negative 3i, you get negative 9i squared. Plus 3 times 3 is 9, and I times I squared. But if you remember what we did last time in complex number, I squared is the same thing as negative 1. So now we can replace this I squared to become negative 1. Oh, actually, I like this. Okay. So, so what we have in this case is x squared plus 9. So this is the FOIL of the x plus 3 and x minus 3i. But don't forget that we still have the x minus 4. So what you need to do next is FOIL it out one more time. So when you FOIL this follow out, x times x squared is become x cubed. X times 9 become 9 positive 9x. And then negative 4 times x is negative 4x squared. And then negative 4 times 9 is negative 36. And usually when you do this, I want you to put in the standard form, high to low power. So you will have x cubed minus 4x squared plus 9x minus 36. And don't forget, because the question asks for the function, so you have to have the f of x. Okay, so don't forget the f of x. So this is, oops, sorry, your answer for question 5. So the thing I always tell my students here is, don't forget that you have to find, sorry, the conjugate of this piece, okay, not the other one, okay. So make sure you guys know it's very important, okay. So question 6 is kind of similar to it, but the only thing that is different is they give you the zeros and they tell us that it's a degree of 3, means that your power is 3. The only difference here is they give you this solution point. Okay. What is this solution point is? This solution point is to figure out AN, or A in this case. Okay. So what does that mean is I can multiply this whole thing with A. You still get the same zeros in this case. So this, how do you figure out what A do we multiply? So that means if I multiply this whole equation, this function by 2 or 3 or 5 or whatever numbers, we still get the same zeros, but your solution point will be different. So this solution point will give us an A. But don't forget, the zeros provided to us, only 2 zeros. There are only 2 zeros here. Okay, so but the question tell us is degree of 3. So can someone tell me what is the other zeros we have in this case? So we have -2. Don't forget, comma, we got 1 minus √2i. So this is all together. How do I know it's together? Because there's no comma in between them. So can someone tell me what will be your third zero in this case? Anyone? We take this friend of yours and find the conjugate of it. So the conjugate in this case is 1 plus square root of 2i. Do we need to find the conjugate of -2? No, because only the root or the I can have conjugates, not the nice numbers or rational numbers. And what we do next, once you find them, you have to figure out the factor of it. Remember, we write this in a factor form. So the factor in this case is what? X plus 2. Now, how do you write this in a factor form? Don't forget, factor form need X. And what I told you, all the sign has to be switched. So this one is a positive, it become -1. This -√2i is a negative, it become positive. So make sure you guys know this. This is very important. And then I have no room, so I'm going to put the third factor form right here, because I need to write that. X, again, this one, switch your sign, become -1. This is positive, it become -2i. And what we need to do next, if you finish write this in the factor form, you have to FOIL. Again, which one I want you to FOIL? I want you to FOIL this follow out. The reason why I want you guys to FOIL that follow out is because it has the I terms. And as usual, when you FOIL this, you got 3 terms here and you got 3 terms here. 3 times 3 is 9. You should get 9 terms, but something can be canceled out. We did this before. So let's FOIL this. So you take X times all this, the second factor. So X times X is X squared. X times -1 is -X. X times -√2x is I is -X√2i. Okay. And then the next one is I take the -1 and I multiply to those. So -1 times X is -X. -1 times -1 is +1. -1 times -2i is positive. I'm going to write this over here. Continuation, +√2i. And then the last one is I will use √2i and multiply to this. So when you multiply this, I'll get +X√2i. Multiply this 2, root 2i times -1 is negative root 2i. And multiply those two, negative, pay attention here, root 2 times root 2 is 2, or root 4, square of 4 is a perfect square of 2. I times I is I square. And we know that I square is -1. So we can erase the I square here and replace it with -1. Okay. So what do you notice when you do this is your I will be canceled. So this I will be canceled with that I. The 2i, one negative, one positive, 2i. So you find out that all your I is gone. So this is the good thing when you multiply these terms. You find out that what you left is really nice. No more square root, no more I. And this is the trick I always tell my students. If you find out there's an I here, means something is wrong. So what I left in this case is x squared minus 2x. So we got two of them. This will give me positive 2. So negative. So 1 times 1 plus 2 is 3. So this is just multiplying this up. But don't forget, you still have to do what? Multiply the last one, which is x plus 2. Okay, you still need to multiply this one more time. So this question is a little bit more difficult. So when you FOIL this one out, you will get x cubed minus 2x squared plus 3x. So I take the x and multiply it. And then I take the 2 and multiply it. I get positive 2x squared minus 4x minus 6. And then I combine like terms. I will get the 2x squared is cancelled out. So what we have is x cubed minus x minus 6. But this is not your final answer yet because we have this given function. So that means that y in this case is equals to a times x cubed, this whole thing. Why the a appeared here not in question 5 is because of this solution point. And if you look at this solution point, you can write this in coordinates. The coordinates here says x is -1, y is -12. So what you do is plug these x and y values into your equation here, and you solve for a. So y is -12. So I'm going to write right over here. So -12. A times x in this case is -1. So you get -1 cubed minus -1 minus 6. So I just plug in my x to become -1 and my y become -12 to solve for a. So this will give me -1. And this will give me +1, and this is giving me -6. Then this, I will cancel them out. So what we have is -12 in this case is -6a. So a in this case is 2. So you solve for a. And what I do is replace this a that we have with 2. That's it. And if you want, you can replace your y to become f of x. That's a function. So your answer for this question number 6 is f of x equals to 2x cubed minus x minus 6. And again, you can leave your answer like this. You do not need to distribute your 2 in there. Okay. That is the time for today. We're almost at this out of time here. So we did not finish this. We got a few more left, 7, 8, 9. We will definitely finish this on Thursday in class. Don't forget this homework, 7.3 homework, online homework. This is due on next Tuesday. I think next Tuesday is April 2nd. Okay. So far, you do have like two homework due on today, which will be 3-2 and 3-3. And then next Tuesday, you got 3-4 and 4-1. Okay. So that's it for today. So I will post this video online. Why 6 is negative? Ooh, that's a good question, Henry. Should be a positive, right? Ooh, so I make a boo-boo here. Thank you so much. Now, if I make a boo-boo here, everything, well, I just need to change the sign. So this is a positive 6, right? Thank you so much for this will be a positive 6. So I make a boo-boo now. So that means that your 6 here is supposed to be a positive 6. Thank you so much, Henry. That means this is no longer negative 6a. This is what? Positive 6a means when you divide both by 6, your a is negative 2. So I make a boo-boo here. Thank you so much, Henry. So that is a negative 2. So it's kind of the same. I mean, just a bit of changing sign here. So, so your answer in this case should be negative 2x cubed minus x plus 6. Thank you so much for correcting me in this case, Henry. Again, as you guys know, that one wrong mistake, it has a domino effect in this case. Thank you for Henry for that case. Yep. So this is the correct answer. My bad for that case. If you have any questions, please seek help. Either come and talk to me or go to the tutor center or go to the math resource center. So very important here. That's it for today's class here. Let's stop this. There you go. And stop recording.